Welcome to The Explainer. Today, we're going to bridge a gap that, let's be honest, every single one of us has faced. Taking that application that runs perfectly on our laptop and getting it ready for the big leagues, the real world of Kubernetes.
I mean, we've all been there, right? This quote just perfectly nails the challenge we're about to dig into. It's that final and often kind of painful leap from your nice, controlled, local environment to a dynamic, distributed system where anything can happen. So to make this real, we're going to follow the journey of an actual application called StreamMetrics. We're going to trace its exact path, taking it from a simple local setup with Docker Compose all the way to a tough, scalable Kubernetes cluster.
And this right here shows you the huge architectural shift we're talking about. On the left, you've got that cozy, simple, all-in-one-place environment. But on the right, well, that's where you get the real power. And yeah, the complexity of a system built from the ground up for resilience and scale. This transformation is exactly what we're going to explore. Okay, let's talk about the first major hurdle. And trust me, this is the one that trips up almost everybody. It's Kafka's networking, specifically how it listens for connections, because it behaves totally differently in Docker than it does in Kubernetes. You know, this is probably the single biggest time suck in projects like this. If you get this wrong, you're just going to be staring at unknown host exception errors for hours, tearing your hair out, wondering why your application can't see a broker that is clearly up and running.
The best way to think about this is like a building with a public lobby and a private staff-only hallway. Your application walks in through the public external door. But once they're inside, the brokers use their own secret internal hallway to talk to each other. You absolutely need both for the system to work.
Now here's the magic. When you move over to a Kubernetes native tool like Strimzi, which is basically an operator built to run Kafka on Kubernetes, this entire headache just vanishes. Poof. Strimzi is smart enough to understand the Kubernetes network, and it automatically sets up all the right listeners for you. It is a massive win for your sanity, believe me.
All right, next up is a classic gotcha. You make what seems like a really smart choice, using a tiny Alpine Linux image to keep your containers small and fast. And then, bam, it uncovers a dependency you had no idea even existed.
Just picture it. Your build is green, your Docker image looks good, you deploy to Kubernetes, and your pod just instantly crashes with this thing. It's super cryptic, it's talking about a file you've never heard of, and it brings your whole deployment to a grinding halt.
And this is the million-dollar question, right? Your code is 100% pure Java. So where in the world is this C++ thing coming from? Well, the problem isn't in your code, it's hiding inside one of your dependencies.
So here's the detective work. It turns out Kafka Streams uses a thing called RocksDB for stateful stuff, which is a super high-performance database. The catch? RocksDB is written in C++. And Alpine Linux, in its mission to be as tiny as possible, just throws out things it considers not essential, like the standard C++ library. It's a textbook case of a native dependency buried deep inside a Java library. And you know what's funny? After all that debugging, the fix is just beautifully simple. You add this one single line to your Docker file. You're just telling the Alpine package manager, hey, go grab that library for me. And just like that, problem solved. All right, let's talk about another classic trap, configuration. I'm talking about those values that you hard code for your local machine, which are pretty much guaranteed to explode the second you move to a dynamic environment like Kubernetes. This was a real-world debugging nightmare. You're looking at the logs, you're checking Kubernetes, you confirm 100 times that the environment variables are set correctly on the pod, and yet the connection still fails. Why? Because of a single, forgotten line of code. So this is the mental shift you absolutely have to make. On the left, that's the trap. Hard coding localhost, because hey, it works on my machine. But that is never, ever going to work in Kubernetes, where your Redis has a proper service name like Redis service. The fix, on the right, is to externalize your configuration. You pull it out of the code and let Kubernetes inject the right value when the app starts up. This is like a fundamental principle for building apps that can run anywhere. So, after battling through all these challenges, what are we left with? Well, we've got a few super critical lessons that honestly apply to pretty much any Kubernetes deployment you'll ever do. This table is really the why. It's the whole reason we go through all this trouble. Yeah, startup time is slower, for sure. But look what you get in return. The ability to scale with a single command, automatic restarts if a pod dies, and resource guarantees so one misbehaving service can't take down the entire node. That's the trade-off you make for production-grade resilience. You see, success on Kubernetes isn't just about writing some YAML. It's about really mastering these operational details. Things like, how does Kubernetes find my images? How does it know if my app is healthy? How do I make sure I'm giving it enough resources? These are the little things that separate a deployment that falls over from one that's truly robust. So getting your app deployed on Kubernetes, that is a huge milestone. It's awesome, but really, it's just the first step. Because being truly production ready means you also need solid monitoring, a plan for persistent storage, automated scaling, and a real CI/CD pipeline. The journey doesn't end here. In a lot of ways, it's really just getting started.